presence of a guru, of a piston guru, Mr. Mark O'Neill, president and owner and guru, designer and everything of Probe Industries. Well, now, Mark, I can call you Mark.
Of course you can.
You know, I know that state-of-the-art is an overused thing, but for you guys to build pistons that don't even require rings anymore, you'll have to explain that to me, because I really don't know anything about the pistons or almost anything that goes up and down like that, apparently. This is a forging. This is the way they come from the foundry. Is that correct? And then you do something to them. You grind them and cut them. And why don't, for my sake and anybody watching, why don't you kind of explain a little about what gets done to these things, what's important to look for in a piston, because they may be buying pistons from somebody else. Maybe they don't have the features you have. Show us a little bit about, I mean, with these two right here that you just grabbed. Talk to us about pistons.
Well, bottom line, from the forging that you started with, the principal thing that the customer is going to be interested in getting a car is getting a part that's consistent in quality of manufacture. And the thing that we do different from every piston manufacturer in the United States, in the aftermarket, is that we're not using a single machine for each manufacturing, for each step of making the piston. We start with a piston, the forging that looks like this. It's going to go into a mill, and it'll have a register cut into it at that time, and the bottom, the top of the piston will be cut just to clean it up. Then it'll clean up the bottom part of the piston and put the pinhole in it, and put the register in it for the remainder of the operations. From that point, it will go into a ovulatory turning machine, which is basically a very expensive lathe that'll turn oval shapes. And in a single pass, we'll use this one because it's a more accurate representation. In a single pass, it'll cut the skirt of the piston, it'll cut the ring grooves, it'll cut the ring lands, and it'll cut the top of the piston as well as the dish. What that means to the customer, although it's a more complicated process than that, but what it means to the customer is every piston is exactly like every other piston because there is no tolerance stacking. You're not moving it from fixture to fixture to fixture. It goes to a single fixture and comes out as a finished part.
Well, that would seem to me like that would give you a higher quality piston if and only that you don't have to keep moving it around from machine to machine. There's no human moving it around and resetting it up and so on and so forth. If you can do it all in one shot, it's got to come out with, as you use the word tolerance, it's got to come out with closer tolerances on that.
Absolutely. The pistons are repeatable within tenths of a thousandth of an inch. The weights are within a gram. There's almost no difference between the first piston in a run and the final piston in a run. There's virtually no difference between them. And it allows you to do a lot of things in those passes. It's got anti-detonation grooves in it.
Well, what is it now? What does that do?
Basically, it breaks up the air going past the top of the piston to the top ring and keeps it from building up pressure to keep a flame front from forming in that part of the piston.
Now, and if it did, what would happen? Well, I mean, what would be the...
That would be detonation, and your top ring could come off the piston.
Probably don't want detonation.
Right, you don't want detonation. No. It allows you to have extremely flat ring grooves. There's almost no waves in the ring grooves. They are double plunged as well, but so you're taking a rough cut and a finish cut to keep them perfectly clean. But the ring grooves are very flat, so you don't get the rings sticking as they move in and out on the piston while the engine is running. It just, from piston to piston, it is just dead solid. And at the same time, it allows you to put the shape here, which is one of the best things about our piston. The skirt was actually designed by Ford. But you'll see almost no wear on the skirt in our piston if you have to pull it out to do anything to it over extremely long periods of time.
Is it true? Somebody once told me that the lower part of the skirt part of the pistons actually aren't completely round.
They're not round at all. They're cammed and they're tapered. This particular piston, an extreme example, is actually shaped. Well, my finger's kind of shaped funny, but it's actually smaller here, largest here, and then gets smaller continually from there, from about ½ inch up from the bottom of the piston to the bottom of the ring grooves. And then it's I'd have to look at the print to be precise, but you're 7 or 9 thousandths smaller at this point than you are in the center of the piston. That allows it when you're starting the motor up, it actually isn't touching at this point. It's closest here, and as it warms up, you'll get your wear surface on the opposite sides of the piston at the center of the skirt. So basically that it's cammed and tapered to account for the growth as the piston gets hot.
On a forging like this, the material that's used, do most piston manufacturers use similar or the same type of material, or what? There's forging sounds like a catch.
There's two popular materials for piston forging. One is 4032, the other is 2618. 4032 allows you to run, back in the old days, allowed you to run tighter clearances. It's higher silicon, slightly more brittle, and is more stable than 2618. 2618 is stronger, and it'll take more abuse before it lets go. So by far, especially in boosted motors and nitrous motors, it is by far the better material to use because it's more forgiving to the tuning prowess of the end user. I'm personally not a fan of 4032. I don't see any purpose for it at this point. Hot rodders don't run their motors 200,000 miles. So the only detrimental effect to running a 2618 in a long-term environment would be slightly more wear in the ring grooves over a period of time. But there are no other materials I'm aware of that anybody's using for pistons today.
How many different types of pistons do you make?
We have 932 part numbers. We make them for all of the American brands. We don't make them for imports anymore. We shelved that project primarily because of it sucked up all the machines and kept us from making enough of the American brand. so we stopped doing it. But we cover Buick, we cover Chrysler, Chevrolet, Ford, Pontiac, even Holdens if somebody happens to have a random one running around.
What about the little holes in the oil ring land? How is it, what's that?
Well, then you're talking about oil drain back. There's a number of, and I wish I had different examples. There's a number of ways of doing it. Bottom line, for oil control, you need one of two things to control oil. You need pressure or you need area. First thing everybody's got to remember is the second compression ring is not a compression ring, it's an oil control ring. It's beveled to control oil, it takes oil off the wall. If you make this area smaller, the third land, and you're running low pressures on the oil ring, as people want to do nowadays, you have to have a way to get it back into the crankcase without it overwhelming, because you will always want more power controlling oil than you do with oil in the combustion chamber. What we do is we use lugs. So we have on this particular, on most of them, and they're larger or smaller depending on design. You can see the two differences here between this Chrysler piston and the small block Chevy. They basically take the oil directly from the cylinder wall and dump it down inside the piston directly on top of the connecting rod, which oils the connecting rod. Another thing we don't do compared to everybody else is we don't use pressurized pin oilers. We don't use them because they don't do anything. They are popular, everybody likes them, and they're just ducky. We've never seen a deleterious effect from not having them in there. And we had some testing done years ago by Roush Racing for Ford Motor Company that indeed proved that there is no difference between having them and not. What we do have on our pistons that's different from everybody else is we have reservoirs in the pin towers away from the bearing surface, which fill with oil and provide constant lubrication to the wrist pin.
There's more to this than I thought.
Well, actually, I'm learning a lot myself.
Oh, Lord. Well, anything else you need to tell us or would like to tell us about this product? You guys sell a lot of pistons, so I know they're popular.
Well, in our pricing category, the pistons are capable of a lot more than most people give them credit for, but they're made in the United States. We make our own wrist pins in-house, so they're made in the United States. all of our forging manufacturers are in the United States. So that makes us a little bit different from most people in our price category who are making them making them offshore and selling them here.
So you're really screwing up the economy in China, is what you're trying to tell us.
Well, not so much China. In this case, it's India and Mexico. But yes.
Okay. Just one more on ACCUFAB TV. What do you think of that?